So just to start, I wanted to remind you that we did the first part of common processes of aging last week, where we talked about free radicals, inflammation, advanced glycation end products, and atherosclerosis. This week, we're going to add to that and talk about endothelial dysfunction, mitochondrial dysfunction, and cigarette smoking. So endothelial dysfunction and mitochondrial dysfunction, we talked about both of these when we mentioned some of the theories of aging and some of the things that could take place and how they were linked together. So endothelial dysfunction is talked about extensively in the literature. However, it's pretty darn hard to actually find a good definition for what endothelial dysfunction is. Remember that the endothelium is what lines the inside of blood vessels. All right, so what would be the dysfunction? Well, the lining of the inside of blood vessels actually release factors that determine whether the smooth muscle that surrounds the vessel will contract and cause it to vasoconstrict, or to relax and therefore vasodilate. And usually there's going to be some type of a balance because those things need to be regulated. Well, endothelial dysfunction in general is when there are less vasodilators than there are vasoconstrictors, meaning the vasoconstrictors are winning the day and there's more constriction. Well, that can do things like reduce blood flow, rate blood pressure, depending on where it's at. So it can do a variety of things. So importantly, it is interesting that endothelial dysfunction typically precedes atherosclerosis, and of course is associated with it because atherosclerosis itself could also lead to endothelial dysfunction. And it's associated with nitric oxide availability. Now, nitric oxide is a short-lived gas that is created, diffuses a short distance, has an action, and doesn't stay around very long. But in this case, we're talking about it because that NO is a vasodilator. In addition, it tends to be anti-inflammatory and anti-proliferative. Now remember, inflammation and proliferation were both parts of atherosclerosis. So nitric oxide would tend to help to keep that at bay. But here, where we have less vasodilators, it's really the NO that for whatever reason is being affected. And there is an impaired production of nitric oxide. So I've added here the chemical pathway by which nitric oxide is formed. And if you take a look at the nitric oxide right here, okay, this is really the primary pathway is coming this direction, although it can happen in this other pathway as well. So L-arginine, arginine, the amino acid, in the presence of this enzyme right here, this stands for nitric oxide synthase, so it's the one that forms nitric oxide. It actually takes an oxygen here, so in the presence of oxygen, and then you can take NADPH, create NADP, and we throw off from that reaction a nitrogen and an oxygen, and that's nitric oxide. Right? So, but this production, for whatever reason, gets impaired. And that's a problem with this particular process. Now, the other half of this that is problematic then is that the nitric oxide is going to be rendered inactive by reactive oxygen species, right? So it's easily damaged by having reactive oxygen species around. And that's at the bottom of the screen right here. I'll bring it up to the middle. They make NO become the reactive oxygen species. That's done by the superoxide anion, and now nitric oxide can't work anymore. So those are two different things that actually take place for the bioavailability of nitric oxide. First, the production is impaired, and second, even the part that is made is rendered inactive. Well, what's going on with endothelial dysfunction? Look at the variety of disorders here that it's associated with: hypertension, hypercholesterolemia, atherosclerosis, diabetes, high glucose levels, high C-reactive protein. Remember, that's a marker of inflammation. None of these are good. And this has a strong association with all of those. And whether it's causative or correlative, it really doesn't matter, because it means that either way, you don't want to get the disease and have this, and you don't want to get this and have the disease. So this is something that happens a little bit more with age. These are things that accelerated. Inflammation, well, that should be no surprise because it was so associated with C-reactive protein. Air pollution, right? And maybe that's due to specific factors that will affect it. And then cigarette smoke. And you'll find that throughout these lectures, cigarette smoke doesn't really do anything good. It only does harm to the body. Can we slow down endothelial dysfunction? Yes, exercise has been shown to do this. Improving the diet, in particular, decreasing trans fats. So trans fats are really an artificial fat. Think of margarine, but also any prepared food product that's placed in a bag and sold, like packaged donuts, cookies, cakes. Often any of these have trans fats in them. Stopping smoking, losing weight, taking medication for your disease, such as something to make you have lower blood pressure or lower your cholesterol levels. All right, next is mitochondrial dysfunction. And you remember, we marked this as one of the primary things, along with free radicals, that I said I think were one of the main reasons for aging. So if you link telomeres, free radicals, and mitochondrial dysfunction together, we can almost account for every other possible cause. All right, this is just a reminder that the mitochondria actually has its own DNA, 37 of them, and these genes are all active in the mitochondria. Not all genes in the mitochondria come from mitochondrial DNA. Some is still made by nuclear DNA. But the mitochondrial DNA you inherited from your mother. Your father did not contribute to this at all. It all comes from your mother. And mitochondrial dysfunction, here abbreviated MD, is associated also with a number of disorders, some of which are certainly aging-related diseases like Alzheimer's disease, Parkinson's disease, stroke, cardiovascular disease, and we talked a little bit about diabetes. In addition, and this should make sense, it's associated with decreased exercise performance because if your mitochondria cannot synthesize ATP to the extent that it can, that's going to cause problems with exercise performance. So here is how this is thought to happen. That the mitochondria produces free radicals. Well, those free radicals then damage the mitochondrial DNA, and this damage can result in mutations, and therefore there's a decline in mitochondrial function. Pretty easy, which means even the mitochondrial dysfunction theory is going to go back to the idea of free radicals. In addition, there is one study that suggests that decreased telomere length ends up with lower antioxidant defenses, and that this causes mitochondrial dysfunction. So now we're also linking it to this idea of telomeres as well. Right, finally, for this particular lecture, cigarette smoking. And even though this is listed under a common process of aging, certainly not everyone smokes, so it may not be common to everybody. But I've listed it here because it is involved with these processes and it's a lifestyle factor. So somebody bringing it in contributes to their own aging process. Cigarette smoke has a lot in it, at least 4,000 different chemicals. And it is not listed here. Oh, it is, at least Roman numeral 4 here, at least 50 of these chemicals are known carcinogens. Some are much higher than others, so they increase cancer risk. And in reality, it's unfair because anything you smoke probably has carcinogens in it. They can be created by the combustion of the product, right? But that means we all know cigarettes can cause cancer. Well, this is the reason why. It can also cause free radicals to be produced. We mentioned that earlier when we talked about free radicals. And so cigarette smoke comes in the body, produces free radicals, causes oxidative damage, and accelerates aging. And I've known people that look much, much older because they smoke. And somebody who smokes throughout their life, and this is probably a pack a day smoker, I can't remember the data, but decreases lifespan by 7 years. That's quite a bit. Moreover, a disease decreases a disease-free life by 14 years. So you get sick way earlier, more than a decade earlier, and then you die 7 years earlier. So accelerates the aging of the skin. That's why people who smoke tend to look a lot older than they really are. Risk of heart disease, not even close, right? The risk factor is way up there. We know it increases risk of cancers, particularly lung cancer. It kills lung cells, risk of COPD and other lung diseases. So there's just, again, really nothing good about cigarette smoke. Finally, just this last little category here. These are all common processes of aging. Can we slow down the aging process? Well, the answer is we don't really have a good handle on it yet, but there is some evidence that good regular exercise will help to do this, that a good diet can help to slow down the aging process, particularly a diet rich in fruits and vegetables, whole grains, low in fat, low in red meats, okay? Low in fried foods, and you get the idea. Stress reduction. And I would add to this, I haven't done any research on it, but if I do, I'll bring it into the lecture here. What if we get adequate sleep throughout our life? Not too much sleep. Too much sleep is bad. Too little sleep is also bad, but we need to get the right amount. And I think that would probably contribute as well. But certainly reducing stress can slow down the aging process. This one has a question mark on it, supplements with a question mark. Can we actually slow down the aging process by buying a can of pills at the store and taking them? Well, the answer, we don't know. It's possible, but I sincerely doubt that all of a sudden that's going to have a magic bullet that's going to do it. But it could be possible, right? People are searching for this all the time. Are there medications that can slow down the aging process? Perhaps aspirin, treating inflammation, certainly helping to prevent heart disease. Statins we saw help to low cholesterol, and maybe you could do some others. I'm going to add in here, even as I speak, uh, the drug metformin, which is an anti-diabetic drug, but they have found activates so many different pathways and so many different things that might actually be something that can help to slow down the aging process as well.